Ever wondered how that little box you plug into the wall can breathe life back into your phone? It's a common sight, isn't it? The drained battery icon, the quick scramble for that trusty charger, and voila, your phone springs back to life, ready to serve your every digital whim. But have you ever paused to ponder the magic that happens within that humble charger? It's an everyday tool, so ubiquitous that we rarely give it a second thought. Yet, this small device is a marvel of modern technology, converting alternating current from your power outlet into direct current that your phone can safely use. It's a complex process, hidden within a compact and portable design. Understanding how it works not only quenches our curiosity, but also helps us appreciate the effort put into making our lives more convenient. So let's dive into the fascinating world of mobile chargers and unravel their mystery. Before we delve into the inner workings of a charger, we need a quick primer on electricity. Picture electricity as a flowing river. The water represents the electric current. The force of the water flow is the voltage, and any rocks or obstructions in the river symbolize resistance. Electric current, measured in amperes, is the flow of electric charge, just like water in our river analogy. Voltage, gauged in volts, is the force pushing that current, akin to the strength of the water's flow. Resistance, measured in ohms, is anything that slows down or obstructs the current, much like rocks in a river. In the context of charging a mobile phone, the current is the amount of electricity flowing from the charger to the phone. The voltage is the pressure pushing that electricity, and the resistance is any obstructions to that flow. With these basics in mind, we are now ready to understand how a charger functions. Now, let's dissect a mobile charger to understand its components. At the heart of every mobile charger, there are three key components: the plug, the transformer, and the circuit board. Starting with the plug, this is the part that connects directly to your power source. Whether that's a wall socket or a USB port, the plug is the charger's gateway to the outside world. It's through the plug that the charger initially receives the electrical energy it needs to do its job. Next, we have the transformer. This little box is crucial. It's responsible for converting the high voltage from your power source down to a safe level for your phone. Without the transformer, you'd be at risk of frying your phone with too much power. Lastly, we have the circuit board. This is where the magic really happens. The circuit board controls the flow of electricity, ensuring that the right amount of power reaches your phone at the right time. It's like the brain of the charger, making important decisions and adjustments to keep your phone safe and well-powered. So you have the plug, providing access to electricity, the transformer, adjusting the voltage, and the circuit board, managing the flow. Each component plays a unique role, yet they are all essential in the charging process. These components work together to ensure your phone gets the right amount of power. But how? Now that we've seen what's inside a charger, let's see how it brings your phone back to life. The charging process begins when you plug your charger into an AC power source. This could be a wall socket or a power strip, for instance. AC, or alternating current, is the type of electricity that powers most of our homes and offices. However, our phones can't use AC power directly. They need a steady current, known as direct current or DC. So, how does your charger make this transformation? Well, it's all thanks to a component called the transformer. The transformer takes in the AC power, and through a process of electromagnetic induction, it converts it into a lower voltage DC power. This is the power that your phone can understand and use. But the journey doesn't stop here. The DC power coming from the transformer is still a bit rough around the edges. It needs to be smoothed out. This is where the capacitor comes in. The capacitor stores and releases energy in such a way that it smooths out the rough DC power coming from the transformer, creating a steady flow of electricity. Now that we have a steady DC current, it's almost ready for your phone. But there's one last step. This power needs to be regulated. Our phones are delicate devices, and too much power can damage their batteries. This is where the voltage regulator comes in. The voltage regulator ensures that your phone receives just the right amount of power to charge the battery without causing any damage. So to sum up, the charger takes in AC power, the transformer converts it to DC, the capacitor smooths it out, And the voltage regulator makes sure your phone gets the perfect amount of power. And that's how a charger breathes life into your phone, making sure it's ready to serve you whenever you need it. As we've seen, a mobile charger is more than just a plug. It's a complex device, a bridge between the wall socket and your phone, converting and regulating power with precision. This little gadget is an unsung hero, silently ensuring that your device gets the juice it needs, safely and efficiently. It's a marvel of engineering, a testament to our technological prowess. So the next time you plug in your phone, remember the tiny powerhouse that makes it all possible.